Well, we have another question here, question H. The question says that the number pi is the ratio of the circumference of a circle of its diameter to its diameter. And then question 1 says, use your calculator to determine pi. Is the number pi a rational or irrational number? Now, to get that, okay, I'm gonna take my calculator, and let's see. To get the value of pi, in the calculator, press the button Shift, okay, and then press the times this button over here, times 10. You see pi just on top of it, and then hit equal button, and then press the ST button. This will tell us what pi is. You can see, notice that the decimal parts are not recurring. Okay, there are no pattern in the decimal parts. They're just not random numbers, but they just there is no pattern. That's what I can see. There is no recurring decimal here. There's no like a certain amount of digit that repeats over and over to be a rational number. Because of that, we say it's a rational number. And then to make sure we can go and see that in a larger screen, okay? If I hit pi here, you can see it's even more digits than it was before. Here it's stopped by there, and then you see there are more digits, and the digits here still keep on increasing indefinitely, and there is no pattern. We cannot notice any pattern over here. Okay, so because of that, we can say that pi is not rational, but it is irrational. Now, question 2 says that question 2 says show that the recurring decimal 3,142,857 is a rational number. Now we can notice that they are, let me write the number first. The number is 3,142,857, and we can notice the dots on top of 1 and 7. The dots here means that all the digits between 1 and 7, 1 and 7 inclusive, are recurring, meaning they repeat itself themselves over and over in that order. Okay, it's gonna be like 142,857, 142,857, 142,857 over and over and over. Now, to prove that it is a rational number, I will let x to be equal to that number. Say let's x equal to 3,142,857. Okay, and then it's gonna be like 142,857 again over and over. I'll let x is equal to that. You can just put dots here to say 3 dots here, the ellipsis, to say that this continues indefinitely in that order. Now, if I times this equation, I can call it equation 1 because we have like equality and an unknown. If I times this equation by 1 million, because there are 1, 2, 3, 4, 5, 6 digits after the comma, I need to times this by 1 million. This will be I write it just on top of this. It's gonna be 1 million / 1,000,000 x, okay, equal to I prefer to write it this way. Because of space, I think, yeah, I want to write it this. I prefer to write it backwards because of space. It's gonna be like 7, 5, 8, sorry, 8, 2, 4, 1, and then 3, okay, comma, yes. So it's gonna be like 1 million x equal to this. So it's gonna be 1 million x. If I times this equation by 1 million, it's gonna be like 1 million x equal to this, comma, excuse me, 14285. 7, 1, 4, 2, 8, 5, 7, etc. Now this is like equation number 2. Okay. If you're unsure how to do that, I would like you to watch our videos on how to find recurring decimal. Okay, in the playlist of the video series. This is equation number 2. Now, if I do equation number 2 minus equation number 1, okay, I will have like 1 million x here minus x, and then this will be equal to 9, 9, 9, 9, 9, 9 x, okay, equal to what? So this might be like 3, 1, 4, 2, 8, 5, 4, because 7 minus 3 will be 4, okay? And then the rest here will just simplify, because 1 minus 1 will be 4, 4 minus 4, 2 minus 2, etc. etc. up to there. So all this will be simplified just to be comma 0. Or I don't need to put the comma there. The answer will be this. Now, we can work out x if we divide both sides by 9, 9, 9, 9, 9, 9. Okay, I'll divide here by 9, 9, 9, 9, 9, 9, 6, 9. Yes. And then x will be equal to, let me use a calculator. 3, 1, 4, 2, 8, 5, 7, okay, over 999, 999. And when we hit equal, this is yes, this is the fraction. We can see 3, 1, 4, 2, 8, what's the 8, supposed to be 5. Why did I get it wrong anywhere? Let me double check. Did I miss? Because it's not really that. Let's see. 7 minus 3 is 4, and then 5, 8, 2, 4, 1. And then 3. Yes. 1, 2, 3, 4, 5, 6. Is that all the digits? 1, 4, 2, 8, 5, 7. Yes. And then if I do this minus 3, 1, 2, 3, 4, 5, 6, 7. Yes. 7 minus 3 is 4, and then we have like 5, 8. In the calculator, 3, 1, 4, 2, 8, 5, 4. Oh, yes, I was supposed to write 4 there. I wrote 7. Yeah, that was okay. At the numerator, yes. If I hit equal, yes, that's equal to 22 over 7. That makes 22 over 7. It is 22 over 7. So this is the fraction of the number 3,142,857 recurring. Okay. Thank you. Now, question 3 says that it has been stated in the past that pi was 22 over 7. Is this true? Use the results in 1 and 2 to justify your answer. Okay, if I look at this value that you got here, 22 over 7 is 3,142,857 recurring. This part is recurring. So because of that, we say it's not really equal to pi, because the value of pi is 14159. So the digits are not really are not exactly the same, you see. So then they're not it's not true the information they say in the past. But I can say it is the approximated value, okay, of pi, but it's not 22 over 7 is the approximated value of pi, but it's not equal to pi. Thank you. Well, we have another question here that says simplify this expression. So we do have 9x squared minus open bracket 3x squared minus 2 raised to the power of 2. To simplify that, we're going to expand this, okay? One way is to do like 3x squared minus 2 times 3x squared minus 2, but I prefer to use the property here. The formula says that for the perfect square, if you have like a minus b to the power of 2, this is equal to a squared minus 2ab plus b squared, okay? So over here, all this 3x squared is my a, and then b is my 2 is my b. Then this will be equal to 9x squared minus, I prefer to write like this, I leave space for a squared minus 2ab, okay, and then plus b squared. Now I can sub in, my a is 3x squared, so 3x squared minus 2a 3x, b is 2, okay, not negative 2 by 2, and then b squared is going to be like 2 squared. Now we can simplify this. We have like 9x squared minus 3x squared raised to the power of 2. Remember this law of exponents. A, b to the power of m. This is a to the power of m multiplied by b to the power of m. And also a to the m raised to the n. This is equal to a to the m times n. Okay, we're going to apply the two laws simultaneously. This power of 2 is for both 3 and x squared. So this would be like 9, and then on the x squared, it becomes like x to the power of 4. That's the law apply. So, and then the minus, you need to be careful here because there's a minus. I prefer to put a square bracket like this. So minus what? 2 times 3x times 2, that makes 12x plus 2 squared is 4. 4 to the power of 2 is 16. Okay. And then the negative sign, if I drop the brackets, the negative sign will change the signs of everything within the brackets, okay? So it's going to be like 9x to the power of 4 plus 12x minus 16. And then simplifying this, we can write negative 9x to the power of 4 plus 9x squared plus 12x. Because wait, 2 times 3 is 6, 6 times 2, yes, that's correct. Minus 16. So that's the solution in this question. Hold on a second. Okay, a is 3x squared. Sorry, I forgot the power of 2 there. 3x squared. So that will be like negative 12x squared, positive 12x squared. Now let's just over here negative 9x squared. No, positive 9x squared plus 12x makes 20 positive 21x squared. So that makes 21x squared, and then there's no 12 here, and then minus 16. That's the correct answer. Now that was question 1, and then question 2, say factorize. Okay, let me write it over here. We have like 9x squared minus 3x squared minus 2 to the power of 2. So to factorize this, you notice that this is 9 is a square number, okay? So it's like 3x squared, 3 squared, and then x squared, okay? And then this can be written as 3x to the power of 2, you see? So now, because this is squared and that's also squared, we have a difference of 2 squares. Remember, we said that a squared minus b squared, this is equal to a minus b times a plus b. So this is the method we're going to apply here. It's going to be like 9x squared minus 3x squared minus 2, like that. I use square brackets here because I have a round bracket already there. And then the other one will be 9x squared minus, plus now 3x squared minus 2, okay, close square bracket. Now we can simplify. That makes like 9x squared, okay, minus 3x squared plus 2. Okay, there's no need to use a square bracket now. Okay, open bracket there, 9x squared plus 3x squared minus 2, close round bracket. And now we can simplify again, 9x squared and minus 3x squared. That makes 6x squared. We combine the like terms. And then 9x squared plus 3x squared makes 12x squared minus 2. So, oh la la, sorry, I meant to write, okay, let me do this one over. It's not really that. It's actually 3x, okay, which is the power of 2. So the difference of 2 squares is between this and that, not with 9, but 3x there. So we're going to write 3x, okay, 3x minus 3x squared minus 2, like that. And then 3x plus 3x squared minus 2. Okay, like this. Now, if I drop now equal, I'll drop the square bracket. It's gonna be like 3x minus 3x squared plus 2. Okay, open bracket. It's gonna be 3x plus 3x squared minus 2. We can just rearrange. It's gonna be like negative 3x squared plus 3x plus 2, and then 3x squared plus 3x minus 2. So I said we have like a difference of 2 squares. This is like a now. 3x is like a, and then what is here in the bracket is like b. So we can say a there, so like a minus b, okay, factors of a plus b, okay, and then we simplify. Thank you. Now we have this question here that says factorize x cubed plus 2x squared plus 2x plus 1. Now to factorize, I will take the common factor there, x squared, and then over here, common factors will just be 1, okay? 1, and then in the bracket, if I take x squared out, I'm gonna left with x plus 2. Excuse me. That will be yeah, x plus 2, and then over there it will be 2x plus 1. Now this, notice that it's not really working, okay, because this part here and then the other parts here are different, okay? Okay, because they're different, we cannot really factorize this way. But now maybe, what if I change the way of grouping these factors? What if, for instance, I group x cubed with 1 and then 2x squared with 2x? what if I do that way? I have like x cubed plus 1, and then plus 2x squared plus 2x. Okay, because x cubed plus 1, we do know this property that says a cubed, the sum of 2 cubed, a cubed plus b cubed, this will be equal to a plus b, okay, and then a squared minus ab plus b squared. Okay, we can factorize that way. So this is going to be like if a is x and then b is 1, I'm saying that because 1 can be is the same as 1 to the power of 3. So these two can be considered as a sum of 2 cubed, okay? So we can factorize it as x plus 1, okay? Open brackets, x squared minus x times 1, that makes x times 1 is just x. And then plus 1 squared, which is just 1, okay? And then these two here, we can take 2x as a common factor, so it's going to be plus 2x common factor. And if I take 2x out, I will be left with x, okay, plus 1. Now again, we have x plus 1 here and x plus 1 there. We can factorize. We can make it like x plus 1 factor of what? X squared minus x plus 1 plus 2x. This 2x here. So we can just take this and that together. And then we can simplify again. So it makes x plus 1 factor of x squared. And then negative x and plus 2x makes plus x. And then plus 1. Now we can see we factorize it fully. Thank you. Well, we have another question here that says simplify the following. So we're like x minus 2 over x minus 1 over x plus 2x over x minus 1. Now it is important to note that here the denominator is 1, okay, and there also the denominator is just 1. Now to solve this, we need to make the denominators of and okay, this line here is the main fraction line, okay. And now we need to find the denominator of the fraction above the main fraction line, and then also the common denominator for the denominator of the fraction below the main fraction line. Okay, so now to do that, we need to find the LCM of 1 and x minus 1. So the LCM here is just the LCM will be just equal to x minus 1, okay? Because x minus 1 times 1 makes x minus 1. Now we can write, I need to change this 1 into x minus 1. So I write like that, 2 over x minus 1. And then the x, and then 1 there minus 2x over x minus 1. To do that, I'll times here by x minus 1. I do the same with the numerator to keep my fraction the same. Over here also I times by x minus 1, and then there I times by x minus 1. Now I have a common fraction, okay, common denominator I meant to say. We can simplify the numerator there. This will be when we times x, and then x times 1 there, the same we do here, okay. That will be x squared minus x over x minus 1 minus, okay, I prefer to write it because now the denominator common, I prefer to write it with a common denominator. I'll say x squared minus x, and then minus 2, okay, all over x minus 1. we combine the two fractions, the numerator, we expand this, and then we combine with that, -2. All over, this is the main fraction line. I'll write here x squared minus x, and then minus 2x, all over x minus 1, okay? Now, we can simplify, and the numerator, it will be, I can try to write it, to factorize the numerator here, because we have a trinomial. We can write the, I'll write somewhere here 2, and the factors of 2 are just 1 and 2. And if I need to get a sum from the factors of 2 that is equal to -1, that the coefficient of x, you know, when you don't see any coefficients, understand it's 1, it's not 0. Okay, you place 1 there, but with the sign, it's -1. To get -1, this must be a +1 and the -2. Okay, so now over there, I can write x there like this, all over x minus 1, the main fraction line now. And then there at the denominator, okay, over here I'll place +1 and then -2. Now the other fraction below the main fraction line, we can combine these two terms because they are like terms. So that makes -3x. So this will be like x squared minus 3x all over x minus 1. Now, you know, to solve fractions like this, the property says, I'm writing my properties here, if you have like a fraction a over b all over c over d, okay, this means that we can just do, we can multiply the first fraction by the inverse of the other fraction. So it's going to be ab multiplied by d over c, not c over d, d over c. So now this fraction will be equal to, I write here x plus 1, x minus 2 over x minus 1 multiply by that x squared minus 3x and x minus 1, okay? So we can then simplify these two. We can simplify because they're like terms, and then the solution will be just x plus 1, x minus 2 over x squared minus 3x. So that's the simplified form of the given fraction. Thank you. Well, we have another question here, question L, 1 and 2. Question 1 says factorize p squared minus 12p plus 32. So we will do as we used to do. We look at the last term, it's 32. The fact that, let me write here, 1 p squared minus 12p plus 32, okay? The fact that there is no, we don't see any coefficient in front of the p squared, we understand it's 1, or the fact that we don't see any coefficient at all, we can just place p within the brackets like this, okay? And then we're going to consider the last term, which is 32. And then I'll write here 32. And then I'll list all the factors of 32. I'll say 1 and 32, because 1 times 32 makes 32. 2 and 16, because 2 times 16 makes 32. 3, not 3, but 4 and 8, okay, for the same reason. And then what next? Oh, that's it. Now, now let's see in the list of the factors of 32 here, the only one couple that will make a sum equal to the coefficients of the middle, -12. Now we can see that we can get -12 only if it's -4 and -8. And of course, the product -4 times -8 makes +32. Okay, you see here the products okay, makes positive 32, and the sum makes negative 12. Now we can place within the bracket here, we can place negative 4 and negative 8 there. Now we did factorize. And then question 2 say, hence or otherwise, factorize a plus b squared minus 12ab plus 32. So this is simple. We can just substitute this. Call ab p. Okay, if I call it p, it is the very same expression that we have here. It's gonna be like p squared minus 12p plus 32. So I'm gonna write here a plus b squared minus 12a plus b plus 32. Okay, this will be, if I call all this like p, if I call it p, now this will be like the same thing here, the same factors we have here. Instead of p, I'm gonna write a plus b. So a plus b minus 4 factor of a plus b minus 8. Okay, note that this is like the p we had there. Thank you. Well, we have a question here. Question says like, if x equal to negative 1 over x equals 7, determine the value of x squared plus 1 over x squared. All right, let's start by writing the question here. We have like x minus 1 over x equals to 7. Now we need to find the value of x squared plus 1 over x squared and also find this value. How can we do that? Okay, let's see. If we raise this part to the power of 2, okay, we set it to the power of 2 and that also to the power of 2. And then we know that this will imply that we can write here first. Okay, now if I use the property that says a plus, no, here it's a minus b to the power of 2, this is equal to what? Equal to a squared minus 2ab plus b squared. I want to apply this, okay? Note that my a is x, my b is 1 over x, okay? So this will be x squared, okay, minus, there's a 2 there, multiplied by a, which is x, multiplied by b, which is 1 over x, okay, plus multiplied by b squared, which is 1 over x raised to the power of 2. Okay, this is equal to 7 squared is equal to 49. Now, if we solve this, we can simplify x and x there, and then this will make like x squared minus 2 plus remember the law of exponent. The law of exponent here that says a over b raised to the power of m. This is equal to a to the m over b to the m. Okay, so this power 2 here is for both the numerator and the denominator here. So 1 squared is just 1. And then x raised to the power of 2 is x squared equal to 49. Now, if I move this negative 2 over, okay, we will get x squared plus 1 over x squared equal to 49 plus 2. Now we have like x squared plus 1 over x squared equal to 51. So this is proven, okay? X squared plus 1 over x squared is just equal to 51, okay? We can do the same for question 2 there. Question 2 says x cubed minus 1 over x cubed equal to equal what? That's what we're looking for. Okay, I don't need to write it over. What is given is that x minus 1 over x equal to 7. Equal to 7. So we can raise both sides, okay, to the power of 3. I meant to write 3 there. To the power of 3. Okay. So if we do that, this implies that we will have like x minus 1 over x, okay, times x minus 1 over x to the power of 2, okay, equal to 7 to the power of 3 is equal to 343, okay. As we did expand this part, okay, I'll say so this part here, let me just we did this, okay, over here we did this, it was proven to be equal to that, so this is the same as that. So I was just gonna substitute it again. Here it's gonna be like x minus x over 1 over x multiplied by x squared minus 2 plus 1 over x squared, okay. This is equal to 343. Then we can times this. We can do x times x squared, and then x times negative 2, and then x times 1 over x squared, and then negative 1 over x times x squared times that, and times that also. Now this will be equal to x times x squared makes x to the power 3 minus 2x plus x times 1 over x squared equal to, not equal to yet, and then negative 1 over x. So we're like negative 1 over x times x squared, and then negative 1 over x plus times negative 2 makes positive. So positive 1 over x times 2, and then negative 1 over x times 1 over x squared equal to 343. Okay. Now can we simplify? We have x cubed there, and then negative 2x. If I do like, I can simplify over here. I can simplify this. Okay, this part here, x times that. We can simplify this. This is just plus 1 over x. And then over there also we can simplify. Okay, we simplify this with that. That makes negative x. And then there we make plus 2 over x. And then minus 1 over x cubed. Now, let's look at this and that one has a same denominator, so we can combine them. So this makes what? It makes x cubed minus 2x, no, not 2x, but 3x, because I combine this and that, and then plus 1 over x plus 2 over x, that makes 3 over x, and then minus 1 over x cubed. Now, if I move these two closer, I can write here x cubed still equal to 343, okay? Now I can say x cubed minus 1 over x cubed, and then minus 3x plus 3 over x. equal to 343. Now, this is what I'm looking for. I need to find the value. Okay. Now, I have like negative 3x plus 3 over x. If you look carefully, you notice something. Let's see. We have like x cubed minus 1 over x to the power of 3 minus, over here, I can take negative 3 as common factor. Okay, if I do that, negative 3 for common factor, I will left with x plus, no, not x plus, but x minus 1 over x. If I take negative 3 out for the common factor over here. Okay, because if we times negative 3 there by x, you got negative 3x. You times negative 3 by that, you got positive 3 over x. Now, this was given to be equal to 7 initially. They said if x minus 1 over x is equal to 7, okay? So this is already 7. All this is 7. And then we will have like x cubed minus 1 over x to the power 3 minus 3 times 7, which is 21, negative 21, equal to 343. So if we move the negative 21 over, that makes x cubed minus 1 over x cubed equal to 343 plus 21, and that makes x cubed minus 1 over x cubed equal to 365. Thank you. Well, we have another question here that says if a plus b raised to the power of 2, in the a plus b in the bracket raised to the power of 2 equal to 10, and ab equal to negative 2, and a is greater than b, calculate the values of a squared plus b squared, a minus b. All right, now we do know by definition what is the formula for a plus b squared. We did say that a plus b squared is equal to, okay, first is equal to 10 as given, and a plus b squared is just a squared plus 2ab plus b squared, that's the formula, equal to 10. Okay, now if we substitute the value of ab, which is negative 2, this will be a squared. I prefer to group as a squared plus b squared, or maybe let's just do it after. We will have like 2 times negative 2 here, okay? And then this will be a squared minus 4 plus b squared equal to 10. And then if I move the negative 4 over, we have like a squared plus b squared equal to 10 plus 4. And that makes a squared plus b squared just equal to 14. Okay? And now we also asked, that was question 1. And then question 2 says we need to, what is the value of a minus b? Okay. What is the value? So let's just put a question mark there. We do know that the formula says a minus b to the power of 2. This is equal to a squared minus 2ab plus b squared. Okay. So I will raise this part a minus b to the power of 2. Now, put it in the power of 2, we will have like a squared minus 2ab plus b squared. Then if I group a squared plus b squared, I put them next to each other, minus 2ab. Okay. And then we see that over here in the previous question that ab squared was equal to 14. So I can sub in there 14. Okay. Minus 2. And then we also, I mean, it was also given that AB was equal to, AB here was equal to negative 2. So we can just say times -2, okay? And then this will be equal to 14. -2 times -2 makes +4. And then a minus b raised to the power of 2 is equal to 18. So we have like a minus b to the power of 2 equal to 18. Now to get the value of ab, it's when we square root both sides. Okay, if I square root here and then I square root there also, we have like a minus b then equal to square root of 18 is 3 roots 2. Okay. Yeah, 3 roots 2, but we can write, sorry, we must write plus or minus, okay, because it generates always 2 answers. Whenever you square root both sides and you have variables and then write, we have things like a minus b, unknown like that, put plus minus 3 roots 2. That's the answer. Okay, thank you. Well, we have another question here that says if a squared plus b squared equal 10 and ab equal to 3, calculate the value of a plus b over a minus b if a plus b is greater than 0 and a is greater than b. All right. We have here, okay, we do know the property. Let's just remind. The property says that a plus b raised to the power of 2 equal to a squared plus 2ab plus b squared. Similarly, a minus b raised to the power of 2 equal to a squared minus 2ab plus b squared. Okay. Now, if I apply these properties, this law of exponents, yeah, I can call it like that, but let's just say perfect squares or just those properties. A plus b squared will be equal to a squared minus 2. AB is given to be equal to 3. I'll substitute AB there by 3. Okay, this will be equal to a squared. I'll group a squared plus b squared. Okay, minus 6. Actually, plus 6. And then a squared plus b squared is equal to 10. So this will be equal to 10 plus 6, and that's equal to 16. Now we have like a plus b squared equal to 16. Now we can find the value of AB if we square root both sides. We square root here, we square root there, and then we get, you know that the square root cancels the power of 2, and then we get like A plus B equal to what? Plus or minus 4. Okay. Now a similar thing we do with A minus B raised to the power of 2 equal to A squared minus 2 AB plus B squared. AB is given to be equal to 3. It's given here in the question. And then if I write those next to each other, A squared plus B squared minus, so it comes now minus 6. Now note that this is the same thing as that again. And then it's going to be like 10 minus 6, and that makes 4. So we're like A minus B to the power of 2 is equal to 4. Now this means what? To calculate the value, we need to square root this side and that side, and then we have like A minus B equal to plus minus 2. Now you know that the square root cancels the power of 2, and then A minus B equal to just plus minus 2. Now it is said we have two conditions. They say that A plus B is greater or equal to is greater than 0. A plus B is greater than 0. Here we have two answers, the positive 4, negative 4. Here we can say because it is greater than 0, so it cannot be -4. So this is equal to +4. Okay. And also this said A is greater than B. Therefore, A plus B over A minus B must be equal to 4 over 2, which is equal to 2. So therefore, I mean A plus B over A minus B is just equal to 2. That's the answer. Thank you. Well, we have another question here. Open bracket ax plus b raised to the power of 2 equal to 4x squared plus bx plus 9. Now, I will write, let me remind you our property. We say that when we have like a plus b raised to the power of 2, this is equal to a squared plus 2ab plus b squared. Okay, this will be equal to now is equal to that. Now I'll say this part here, we can extend it to this form. It's gonna be I prefer to use brackets first. It's gonna be like, okay, let me write ax plus b raised to the power of 2. I use brackets. This is gonna be like because this is my a and then this is the b, so it's gonna be like a squared, okay, plus 2ab plus b squared. Now I can substitute a is ax, so ax plus 2ax, ab, b is b, and then plus b squared. Now this will be equal to, that makes a squared x squared plus 2ax, let's say 2abx, and then plus b to the power of 4. Okay. No, b to the power of 2. There it wasn't b squared, it was just b. Okay. Now the question says that this is equal to 4x squared plus bx plus 9. Now it is important to note that when we have an equation like this, because I just expand this part according to the formula is this, and then they say this is equal to that, so we say this equal to this. Then we can only equate in an equation like this, we can only equate like terms, okay? So we can equate this with, I don't need to take the whole thing, I can just take a squared equal 4 because the two terms ends with x squared. Then I can also say 2ab equal to p, okay, because they do end with p. Let me just change the color. So yes, 2ab equal to p, and then we can also equate the constant term. So this means this simply means that a squared equals to 4. So a will be that means that a will be equal to 2. Okay, because when we square root both sides, we get 2. Or 4 is like 2 squared, and then we can just cancel the exponent and then say a equal to 2. And then we also have like 2ab equal to p. Now, before I do 2ab equal to p, let's first work out b squared equal to 9. Or from here, we can say that b equal to 3. So I don't really need to calculate this. I don't really need, because I have a, b. Oh, let's say also I have the value of p. Then fine, we can do that. we know the value of A and B, so it's like 2A, B equal P. So we can sum in the value of A is 2 and the value of B is 3, and it's 2 times 2 times 3, so that makes 24. So that makes that P equal to 24. Thank you. Sorry, not 24 by 12. I meant 12 because 2 times 2 is 4, 4 times 3 is 12. Now we're done. Thank you. Well, the question says calculate without the use of a calculator this expression we see there. I can write 2011 multiplied by 2012 minus 9 can be written as we can apply difference of two squares here. Okay, it's just because this is a square, e squared, and then 9 is also a square number. It's like 3 squared. Same also, 1 is like also 1 squared. So we can do over there 2012 minus 3 in the bracket like that, and then 2012 plus 3 multiplied by 2013, okay, all over 2015 multiplied by 2012 minus 1, and then 2012 plus 1. Now we can simplify this, okay? It's just 2011 multiplied by 2012 minus 3 is 2009, okay? 2012 plus 3 is 2015 times 2013, okay? All over 2011 multiplied by 2015, sorry, multiplied by 2011 multiplied by 2013. Now we can simplify, okay, this 2011 with 2000 at the denominator, this with that, and the answer is just 2009. Thank you. Well, the question says factorize the following. Okay, let's start by writing question 1. You know, we need to factorize this. What can we do here? I think it is important to note that okay, the fact that the leading coefficient or the coefficient of x squared is a fraction, I would prefer to write each term in terms of the I need to write everything with a common denominator, okay? So the denominator here is 1, and there also is 1. So I can write it like a half x squared minus x under 1, like that, minus 4 over 1, x over 1. So our times here by 2 to make the denominator common. Our times also by 2 to have it to make the denominator common. So this will make a half x squared minus 2x over 2 minus 8 over 2, okay? Now, we can take a half for the common factor, okay? If we take a half common factor, we will have x squared minus 2x minus 8. Then we can factorize here. So it's going to be like a half, open bracket, x, close bracket, open bracket, x, close bracket. Now, I'm going to look at the last term, -8. I'll write -8 there. The factors of -8 are 1 and 8, 2 and 4. So if I need to get a -2, it's only possible if it's +2 and -4. So I'll say -2 here and then +4. Up the other way around. -4 and +2. And then we factorize 1. That was question 1. Okay. The same we're gonna do in question 2. Same thing. We have like a denominator here, which is 2. So we need to write each term in terms with a common denominator. So 3x squared. Initially, this has 1 at the denominator, that's also 1. So over here it's like over 1 minus 7 over 2x plus 1 over 1. So I change this times here by 2, times here also by 2, times here by 2, and then times here also by 2. Now this will become not 3 but 6x squared over 2 minus 7 over 2x plus 2 over 2. Now we can take a half for the common denominator, the common factor, I mean, and then there will be 6x squared minus 7x plus 2. Can we then factorize? Note that over here we have a coefficients which is different than 1. So we do as we usually do, we're going to do 6 times positive 2, which is 12. Okay, I write 12 over here. And now I list the factors of 12. They are like 1 and 12. Okay, because 1 times 12 makes 12. 2 and 6 for the same reason. 3 and 4 also. Now, which couple here can make a sum equal to the coefficient of the middle term, -7? We can see it's only 3 and 4. So this is possible if it's -3 and -4. And of course, note that -3 times -4 makes +12, and -3 minus 4 makes -7. Now, over here, we can split it into 4 terms. So instead of writing -7, I will be writing -3x minus 4x, okay? And then plus 2 there. Now this will be a half, excuse me, a factorized by grouping. For the first two, for instance, here these two, I'll take 3x common factor. And then for the last two, I'll take -2 for the common factor. Okay. And then this will be 2x minus 1, and then also 2x minus 1. Careful here. When we take -2 out, it's going to be 2x minus 1 in the bracket. So this will be a half. I don't need square bracket. Now, note that we have this and that common. So we can just say 2x minus 1, the common factor, and then 3x minus 2. Then factorize this. The same way we will do question 3. This one. Over here, we're also going to make the denominator common. You see, to do that, we must times here by 2, there also by 2. Here we times by 7, there by 7, and there we times by 2 to make the denominator common. Okay, and maintain the fraction as it was. So I can write here question 3. The 1/7x squared plus a half x plus 3/7. Okay, so our times here by 2, and then also by 2, times here by 7, and then also by 7, and then times here by 2, and then also by 2. Now the fraction will become 2/7x squared plus 2/14. Okay. 2/14 x squared plus 7/14 x plus 6/14. Now we can take 1/14 for the common factor here. Okay. And then this will be, we're left with 2x squared plus 7x plus 6. Now we can factorize. We're going to times the first, the coefficient of the first term with the constant term. 2 times, we do 2 times 6, which is 12. And then we're going to list the factors of 12. They are 1 and 12, 2 and 6, 3 and 4. So now if we need to get a sum equal to the coefficient of the middle term, positive 7, you note that we can get 7 only with 3 and 4. And then if it's positive 3 and positive 4, then this can be written as 1 over 14, open bracket, 2x squared. Instead of me writing like positive 7x, I'm going to write plus 3x plus 4x. Okay, knowing that these two derive from 7x plus 6. Okay, and then this will be 1 over 14, open bracket. I can use square bracket now. Let's use square brackets. The common factor between this and that is x. So, and then the common factor between these two is just 2. Okay, and if I take x common factor for the first pair, we will be left with 2x plus 3. And then for the last two pairs, it's going to be 2x plus 3. Note that what is in the bracket here must always be the same. Otherwise, either the factorization here is incorrect, or we did selected the wrong couple of factors of 12 here. Now, this will be equal to 1 over 14. So 2x plus 3, and then x plus 2. Done. That was question R. Okay, thank you. Well, we have another question here. Question S says simplify these expression. Now, note that we do have like a negative exponent here. There is one of the property that says if you have like a to the negative m, this can be written as 1 over a to the m. Okay, another property says that a over b, okay, divided by c over d, this is equal to let me move a little bit. This is equal to a over b multiplied by d over c. Okay, so x raised to negative 2 can be written as 1 over x squared minus 1 over y squared, okay, divided by 1 over x plus 1 over y. I don't really need to write power of 1, okay? When the power is 1, I don't have to do that, to write it. Now, over here, I can combine, I cannot really apply this property here as yet because we don't have like a, it's not one fraction. Here we have two fractions within this bracket here, same as here. We need first to combine to combine the fractions. To do that, I'll times here by y squared, times by y squared there also. I times here by x squared, I times here by x squared, times here by y, times here by y, times here by x, times here by x. Why? Because I'm trying to write all of them with a common denominator. Okay, so now this will make what? Y squared minus x squared minus x squared over x squared y squared, okay, divide by y plus x over xy. Now this will be equal to y squared minus x squared. I can apply the difference of two squares. Remember, we said that a squared minus b squared, this is equal to a minus b, and then a plus b, okay? So that will be like y minus x, y plus x over x squared, y squared, multiply here. This is the property that I'm applying here. We multiply now by the inverse of this. So it's going to be like y plus x under xy. Now, I want you to notice here this y x squared y x squared y squared, they both have same exponent, so we can combine them by writing like the power of 2 there, and then in the bracket I write xy. We can do that, and then now let's simplify. We can simplify fraction across. We can simplify x plus y is the same thing. X plus y and x plus y here we can simplify, and then xy and then one of the xy there, because xy squared is xy times xy, so I can cross one xy, and then the answer is just y minus x over xy. Thank you. Well, I have another question here that says if the product of two numbers equal to 40 and the sum equal to 20, show that the sum of the reciprocals is equal to a half. Now, let's say the two numbers are x and y, okay? So it means that x times y equal to 40 and x plus y equal to 20. Then let's say show that the sum of the reciprocal is equal to a half. The reciprocal of x is 1 over x, and then of y is 1 over y. So therefore the sum will be 1 over x plus 1 over y equal to a half. In other words, if you combine the fractions here, so meaning if I times here by y, I times here by x, I times here by y, I times here by x, excuse me, I times here by y, okay, there are terms by x and there are terms by x. This will be y over, it's going to be like y plus x equal to xy equal to a half, or basically y plus x is something as x plus y, okay, over xy equal to a half. Now, now let's see. They said we need to, first of all, we had like x times y equal to 40, and then x plus y equal to 20. Now, the product here is equal to 40, so I sub 40 there, and then the sum here is equal to 20. So let's do it. Oh no, let's do it over here. We will have like 20 because this is the sum. 20 over 40. This is the product, okay, equal to a half. Now, yes, of course, 20 over 40 is a half. We have a half equal to a half. We have proven, okay, left hand side equal to right hand side. Thank you.